Hi, this is Mrs. Dubois. And I'm going to go over practice 3, systems of eliminations with special cases. And this is a complement to yesterday's Desmos. All right, to refresh our memories or warm up again on elimination, we are looking to see if we can add and wipe out or eliminate one variable. So we can see here that we can add in order to wipe out the y's. So 4x plus x is 5x. Negative 2y plus 2y is 0, so that eliminates. And negative 2 plus 17 is 15. I have a one-step equation, divide by 5, and I have half of my answer because remember, the solution is an ordered pair. Now, I'm going to pick the second line. You could pick either, but I picked the second because it's all positive. And I'm going to plug in a 3 for x. Now I have my two-step equation. I subtract 3 from each side. 2y equals 14. I divide by 2. Y is equal to 7. So if I were to graph that on Desmos, they would intersect at the point 0.37. I'm going to apply the same philosophy to number 2. I'm going to add them. And when I add a negative 4x plus 4x, they eliminate or wipe out. And if I have negative 2y plus 1y, you can write a y here to help you out. You get negative y equals negative 3. And you can't have a negative variable, so we're just going to take the opposite. The opposite of a negative y is y, and the opposite of negative 3 is 3. Again, here we go, a great beginning. We have half our solution. So in order to find x, again, I'm just going to pick the second line, 4x plus y equals 11, just because that is all positive, and I just like to deal with positive numbers, but you certainly could have chosen the first line. So I'm going to plug in 4x plus 3 equals 11, draw my line, my two-step equation, subtract 3 from each side. I'm going to get 4x equals 8, divide by 4, and x is equal to 2. Again, this is the point of intersection, 2, 3. Now, the next 6 problems, we're going to look at some special cases, all right? So in this one, we can add, all right? And when you do 6x plus a negative 6x, the x's wipe out. And actually, if you're looking, negative 10y plus a positive 10y is also equal to 0. And a negative 17 plus a negative 68 is negative 85. So that is a false statement. 0 does not equal negative 85, meaning there's no solution. Now, I would like you to bring these two equations into Desmos. And when you do, you will see that this is just a sketch, but you have parallel lines when you bring them into Desmos. Again, meaning they don't intersect, so there's no solution. Okay, for number 4, I'm thinking, can I add to wipe out a variable? I can't add, but what I can do is multiply the top equation by negative 1. And when I do that, I'll have negative 4x minus 4y equals 12. And then I'm just going to take this second equation and rewrite it right underneath. Remember, you want to keep the x's lined up and the y's lined up. Now, when I add this one, negative 4 plus 4x is 0. That eliminates. Negative 4y plus 4y equals 0. So that eliminates. And positive 12 plus a negative 12 is 0. Now, 0 does equal 0. So this is a true statement, and that means there are many solutions. When you bring these two equations into Desmos and graph it, and you're going to have to draw it, it looks like you only have one line, but in fact, it's one line right on top of the other. And you can kind of visually see that they're the same. The top one is 4x plus 4y equals negative 12, and then the second equation is 4x plus 4y equals negative 12. Let's see if we find some special cases on the next page. So 5, I'm looking, I cannot add and wipe out a variable. So I have to multiply by a -1. Remember, you have to distribute that -1 over everything. So I'll get -x minus y equals 3. And then I'm just going to rewrite the bottom one right underneath it. Make sure that you line up your variables. Okay. And then I'm going to add -x plus x is 0. -y plus y also eliminates, so you get 0. 3 plus 1 is 4. Again, it's a false statement. 0 does not equal 4, so it is no solution. Okay. And when you put those into Desmos, they will graph out to be parallel lines. And that is no solution. If we move on to example number 6, again, we're posed with the same thing. We can't just add those and wipe out a variable, so we have to multiply the top one by -1. It's a common practice to make our life easier. That way we can add, okay? So you have -4x minus 2y equals 2. And then I'm just going to write this equation right underneath it. 4x plus 2y equals -2. Ta-da! And we're adding. So the x's eliminate, the y's eliminate, and the 2 plus a -2 is also 0. So this is a true statement. 0 does equal 0. So this is all real numbers. Again, you did see this yesterday in the activity, that when lines graph out. So this is going to look like one right on top of the other. So this one is all real numbers, or infinite solutions. Okay, on the last page, oh, lovely. I see that I can add this just as it is. And -x plus x is 0. -y plus y is 0. And then -4 plus -2 is -6. So you'll get 0 equals -6, which is a false statement. 0 does not equal -6. Therefore, it has no solution. When you graph out the lines, they will be parallel. Again, they will not intersect, and it will be no solution. All right, 8. Again, we cannot multiply, add them and wipe out a variable, but we can multiply the top one by a -2. And that will give us -2x minus 2y equals 10. And then I'm going to bring this one, 2x plus 2y equals 20. And then we're going to add. This will wipe out. This will wipe out. So you'll have 0 equals 30, which is a false statement. 0 does not equal 30. So again, no solution. Okay. And these will also graph out to be parallel lines. So they do not intersect, so there's no solution. Okay, and what do you notice about the solutions of the graph? So what you should notice is, and this should be your own words and your own thoughts, 1, if there's one solution, you get intersecting lines. If there's no solution, the lines are parallel. This is the symbol for parallel. And if there are many solutions, they're the same line. All right, so keep those three things in mind. Thank you.